Come on, light bulb, you can do this. You can do it. There it is. Classifying triangles. Classified information. There it is. So the way I do this, the first one, 2 marks attached there. I don't know if you see it. There's a straight line right there, which makes a 180. That tells us that this has to be 60, right? They have to add up to 180. Same thing over here. You should see, okay, that's a straight angle, 60 degrees right there. So you've got 2 out of the 3 taken care of. You can just say supplementary, supplementary. That's what you've used there. And then the third one is 60 as well. You use sum of triangle to come up with that third one. What kind of triangle is that? Equilateral. That's it. And always remember, you've got, isosceles, equilateral, and scalene to pick from for the first name. And then you've got acute, right, obtuse to pick for the second name, right? So right, you're looking for this symbol, then you know for sure it's going to be that one. So here we go. This one in particular, I want you to remember side, 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 which is cosine law. You should have on your study sheet indication that this scenario calls for this formula right here. Where these two are opposite each other, right? If you want to find angle A, you better have side A squared on that subtracting spot right there. Which angle should you pick in this case? I would pick the one that's across the 6. Yeah, I would investigate. You can solve for any angle, don't get me wrong. You can solve them all, but it's too much work. I'm going to call this angle A. So to figure angle A, remember you have to add and then subtract. So I'm going to add these two, 3 squared plus 4 squared minus 6 squared, and then it's 2 times 3 times 4. And then you have 9 plus 16 minus 36. You can type it in with the squares, that's fine. That's negative 11 over 2 times 3 times 4, which is 24. Here you have to be careful. My calculator, I can go negative 11 divided by 24. That's negative 0.458 and something. Okay. Angle A, can you stop there? It depends on what I ask you for, but technically you could say, what does this negative tell me? What kind of angle are we looking at? Obtuse angle. You're expecting an obtuse angle. You can technically, in this scenario, I would have been okay if you stopped there, but we're reviewing, right? So let's go ahead and find out what this is. So cosine inverse, negative 0.45 something. Angle A is shift cosine to call inverse, 117.28. Remember that. If you're using cosine law and you get a negative, it's going to be obtuse. So therefore, can we name this thing? We can stop because it's like we've got that obtuse angle. So therefore, it's obtuse. And because all three sides measure differently, we are done. We say obtuse scaling. By the way, do you remember if you get a 0, you're listening, right? You're looking up top. What happens if you get a 0? If you punch this in, you get a 0. Anybody remember? It's going to be a 90-degree angle. If you ever do that, you know what? You can forget about it and just be like, oh, it's 0. I'm going to go inverse cosine of 0, and you're going to get 90. Watch. Shift cos of 0, you get exactly 90 degrees, right? So maybe that's something worth mentioning just in case that happens. Okay, next. This one right here. I can already confidently say that one of the names is going to be right because of that. So half a mark already, or 1 out of 2. Now you need to check for the other side. This is one of the legs, correct? This is my hypotenuse. So I'm just going to call it leg. To figure out the leg, I'm going to take the square root of the hypotenuse squared minus 9 squared. So leg is going to be root of, if I do this first, you get 81.052. So leg is, if you take the root, is 9. JC, I'm going to have to talk to you later. I don't know. Oh, you use sine law. That is my bad. This is a bad example. Because if you use sine law, you get 44.99, which makes it scalene. But my answer will be isosceles. It's just a bad example. So you stick with your answer. If you got scalene, you stick with it. Right, it's right scalene or right isosceles. For me, because this is 9 inches, it's isosceles. I'm going to make sure that doesn't happen. Because the 9 here is also the 9 there. So for me, this is isosceles. Yeah. You can do either or. Yeah. To be absolutely safe, just go acute equilateral. You will not be wrong. Okay? A blast from the past, guys. Good old days. Go ahead. Okay, D, pay attention to this because I'm reviewing trig here. That's really classifying as a side gig. Trig is what I want to make sure you understand. What law am I using here? Side angle side. If the 55 had been here, I'm going to erase it. That side angle side. When the angle is sandwiched between the two sides. But what you should try to remember is that there's a pair. It's always sine law. If you have a pair, how many times do you want me to say it so you remember? If you have a pair, it's sine law. If you have a pair, it's sine law. Should I make a rap song? I don't know. My oldest son, I told him the idea at dinner table, and he's like, yeah, one of my teachers used to do that. And so the one song that he remembers was like, how did it go again? Mean, add them and divide them, and the average will be seen. And so the teacher would just rap the whole time. It's like pretty cool. So I got inspired by that. So maybe next year it's happening. Stay tuned. Okay, sine of A. Okay, you gotta have sine attached to the angle. You don't know what that angle is, but you do know the side across from it. And you got to pair them up like this, or else you will get it wrong. Okay? Don't remove sine. Sine of A. And you multiply and you divide. So you go 22943 times sine of 55. Go ahead. Divide by 200. You multiply, you divide, you get 0.9396. Is it 9396 or is it 4396? 93? Okay. And that keeps going. Angle A, I'm going to go sine inverse of that. So angle A is 70 degrees. If you round it, it's 69.996, right? So you round that to 70 degrees. 70. So you know that this is 70. What else can you check for C now? It should be easy. Angle C is 180 minus 55 minus 70. And that is 55 degrees. Hey, does that ring a bell? If you've got two angles that are the same, it's an isosceles. You know, these two sides will be the same as well. So we know it's isosceles. And what else? Acute, correct? Acute isosceles, because all angles are less than 90 and two angles are the same, which indicates to me that two sides are the same. Could you have continued sine law to figure out the side length? Yes, you could have, and you would have had, your answer would have been 200 centimeters. I can guarantee you that if you did it correctly. But I'm stopping there. You don't need to do that because you know properties, right? It's a little overkill, these questions, they are. But I'm reviewing trig. That's why I'm doing that. Let's sketch this. It's tricky and sketchy. There you go. Acute scalene. I'm going to just, you know what, try your best to make it look like all three sides measure differently. That's my classic scalene right there. And then I go like this, turn, 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 like that. And it says acute, correct? So I'm going to make sure, I don't know, you want to start with 50? I'm going to make this 50. I'm going to make this 60. 70? Okay, sure. Because Aiden said so, right? Aiden said so. So that's 120. So this is 60, right? There we go. Just make sure they're all less than, and they add up to 180. Okay. Obtuse isosceles. I tend to, right, make sure this is my obtuse here. Sure. Makes my job easier. And then I just connect them. And just tell me that these two are the same. 130, you say? Okay, 120. Stick with 120. That's how you do it. Like, it's just that simple. Obtuse scalene. So I'm going to make an obtuse again, but I will make one of the sides a little longer. What do you think, Aiden? I'm going to go 179. You can, right? It's just a really big angle. These other ones would be tiny, but it's still possible. So what do you think? 159? 179, keep it? 0.999. Anyways, obtuse scalene. So dun, 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 there. Or if you don't like that, you can go here. You have to be careful with numbers. So I'll just leave it like that because if it doesn't add up. Right scalene. Just make a right triangle. Make sure you have that box there, and you make sure all three sides measure differently. Hey, we can do one upside down if you want. We can do one like standing up. You do whatever you need to do to make that happen, okay? Um, just keep this one. Just keep it. Put it, if you could put it in your booklets, then it's kind of like it's gonna act as a lesson. We're gonna keep going though, guys, because time is escaping us. Okay, so you gotta hang in there with me. We have our AC going. It's nice and cool. We just rode an AC. That's also cool. Not. So we're gonna go to. I'm gonna skip a few pages, quite a few pages actually. We're gonna go to page 25.